All right, hello everyone and welcome. We are going to get started on our discussion of topics in the second half of week 3 here. And last round we started out with a bit of peer review of your week 3 submissions. Your week 2 compositions, and that was from Angry Bots. And you have completed all of the music and sound effects for Angry Bots. And so today we are going to talk about implementing that into the game using Wise. Last round also we got into a discussion of how to set up your music and sound effects for 2D platformer. And so we're going to use a lot of these same techniques and a lot of the same approach to do the same thing for our second game. And then we are going to turn it over to the class archive, which will discuss a lot of these game audio tools like audio middleware and game engines. Here in week 3, we have certainly turned our focus more towards the technical side with the tools and software that is used to actually get your music working in the game. And next week, we will wrap it up by doing a video capture of your music and sound effects working in the game. So make sure you get started on these assignments as early as you can to make sure that if you run into any sort of technical issues, you have an opportunity to contact me and we can work out anything that you might have had issue with. So for right now, we're going to talk about getting set up and preparing your audio and your files to work in the Angry Bots game project. So I'm going to switch over here to FSO, and here is the class page, and I am on week 3, and I'm going to be discussing this assignment here, Angry Bots Wise Setup. We already went through the 2D platformer Wise setup last round, so make sure you start out by downloading all of the files that are provided with the assignment. You have the Angry Bots Wise zip file. This is the actual Wise session that is provided and that we will be using to set up everything and make it work. Then you have 2 PDFs. You have an asset list PDF. Let's open that there. And you have, oops, I wanted to download that. Well, go up right here. There it goes. And then you also have the Wise Setup Workflow PDF for Angry Bots. There it goes. Make sure you download both of those. Those will give you all of the information that you will need to get working on this project, and I'll be referencing them throughout this discussion here. So just to take a quick peek at those, the asset list is a list of all of the sound effects that are going to be used in the game, and also all of the music files. Gives you information about the properties of these files and how they're going to be set up and used in the game. I'm going to start out with a discussion of the music, getting that set up, and then I'll switch over to the sound effects and discuss this in more detail. There is also slides that goes step by step with how to go through this project, and we'll discuss a lot of the same stuff that I'm discussing now. Some people find it easier to go through the PDF and the slides. Some folks will follow along with the video. I'll also discuss everything here in the class archive. So there's a lot of different sources for information, and if you have any sort of issues, again, please contact me and we can work anything out that is needed. All right, so I have downloaded everything that I need. I'm going to go ahead and create a folder on my desktop and organize all of my files in here and do all of my work in this location. I'm just going to create a folder called Angry Bots. We have found previously that, oh, looks like I've already done that. Well, I'm just going to get rid of the other one. Let's try that again. Angry Bots. We have tried this and have students, they had this folder buried somewhere deep in their own folder structure, and it's caused issues in the past. So I always tell folks to build the session on your desktop so you have quick and easy access to it. So in this Angry Bots folder, we are going to place a couple of files. I'm going to start out by taking that zip file, the AngryBots Wise zip file that we had. I'm going to unzip that, and I don't need to keep the zip file, I just need the folder. All right, so I unzipped the Wise session archive file that was downloaded from FSO, have a copy of that. I'm also going to bring in a copy of the asset list and the PDF, just so I can have quick and easy access to those. Then, what else am I going to need? I'm going to need a copy of the game. You can find this back in the original composition assignment on FSO. If I go back on FSO and I go check out week 2, you should probably already have a copy of the game somewhere on your computer. But if you need another copy of it, you need to find it. It's here in week 2 under the Angry Bots composition. You can download this zip file and it will contain a copy of the game. So I'm going to go get my copy of the game, which is right here. All right, so we need those files. And the next thing I'm going to do is get a copy of all of my music and sound effects. I'm just going to create another folder here called Media. And in that folder, I will create 2 folders, one called Sound Effects and one called Music. And then I can, somewhere on your computer, you have a copy of the files that you turned in for your previous assignments. Go find a copy of your music. Go find a copy of your sound effects. Let me do that myself here. Here in week, let's see, Angry Bots Wise, right here, I have a copy of my music. These are all my music files. So I'm going to bring that over. And then I will get a copy of all of the sound effects. Now, for the sound effects, I have all of the sound effects together in the same folder. Now, let me go back to the sound effects assignment and show you what I'm talking about. So I'm just going to take a copy of all of the sound effects and bring them into the sound effects folder. There it is. So let me explain a little bit about this for just a moment. If you go back to the sound effects assignment on FSO, which is right here. So I'm going to back out again, and this time I'm going to go check the sound effects assignment, or the sound design assignment. So there was a folder or a zip file that you downloaded, and in this zip file it contained 2 folders. One that was called To Use and one that was called To Replace. So you probably recognize this from the sound design assignment. So the To Replace sounds, these ones were required by the assignment. These are 22 files that are required by the assignment. You are going to create your own custom version of these. The To Use folder These are provided with the game. They are not required to create, but you need to have a copy of these. So if you wanted to create all of the sound effects in the game, you also needed to replace these. It was not required for the assignment, but we are going to also take a copy of these. So that's what I've done there. You want to make sure that, go back here and get rid of this. So here's my sound effects folder. I have a copy of everything from this to use, and the ones that are set to replace, you have your own custom version of these. These are what you turned in with the sound design assignment. Also drag those to this sound effects folder. So you have any sound effect that is necessary for the game in the sound effect folder. You have the music files there ready to go. You have a copy of the game. You have the zip file that was downloaded. The PDFs really are there for reference. So this should be everything that we need to get started. Certainly a couple of steps there to make sure, but this is very much what we did last round for 2D platformer. We made sure that we had all of the necessary files to get started. All right, so now I am going to go ahead and launch Wise. Not the launcher itself, but make sure you are launching Wise 2016. And I'll take a moment, let that load up. I'll take quite a few moments and let that load up. So we are going to start out with the music system. We are going to import all of our music files. We will set them up appropriately, and then we will start working on the sound effects. So let's go ahead and you probably don't have anything here in the recent projects. It might be blank. It might say 2D platformer. Don't worry about any of these. Just go ahead and choose Open Other. And then you're going to navigate to your desktop where Angry Bots is. And in the Angry Bots folder, you will load up Angry Bots Wise and find the Angry Bots Wise project. Launch that. Let it take a moment to load up. If it doesn't load up correctly, I'll point something out here. Make sure you have the entire Angry Bots Wise project folder. Some people might just copy this file over or not include all of the files. You need all of the files in that zip folder to have this work properly. All right, so we will start out by bringing our our music into Wise. We are going to set it up in a vertical arrangement. We are going to set it up so that the multiple ambient and action cues can play together at the same time. Just really quick, we are in the designer layout. We want to make sure we're starting there. And I'm going to be switching back and forth between these audio and events tabs. That's mostly where I'm going to spend our time here. And I'm going to start out in the events tab just to show you that there are events already set up and ready to go. Well, they do not have any audio in them. That's your job. You're going to plug your audio in to make sure they work. But there are a couple of music events that we will be using, and then quite a few sound effect events we will set up. So the events are already provided. We are going to import our music and sound effects in here and get everything set up. So I'm going to start out with my music. We have the master mixer hierarchy, actor mixer hierarchy, and the interactive music hierarchy. Basically, buses, sound effects, and music. We'll start with our music here, and I'm going to import all of my music files and drag them onto this default work unit. So I'll move this out of the way. I'll go into my media folder and find music, highlight all of these files and just drag them into Wise, right on top of that default work unit under interactive music hierarchy. Once you've dragged and dropped that, you will find the audio file importer window opens up. There's a lot of settings in here that could be changed, but the defaults will work for us. So we just go ahead and hit import. And it's going to bring in each one of our audio music files. And let's let this redraw here. We see music ambient, music buzzer action, music buzzer stinger, music mech action, music mech stinger, spider action, spider stinger. We have all of the different audio files brought in. Now, if I open up any one of these and we hit a plus right next to it, we can expand it out and we'll see that the actual audio file is here in blue. This represents the WAV file we dragged in, and the WAV file is inside of a music segment. And these music segments are going to be important and allows us to combine our audio files together and gives us some properties that we're going to use. Just to show you what's going to happen here, I'm going to go to the Layouts menu and switch over to Interactive Music. And here I have the music ambient music segment selected here. And if I expand this up, you'll see that I can view the music segment editor right now. While this music ambient in blue represents the WAV file, that represents the waveform, the wave data that's sitting here. Music ambient, the music segment, represents the track, it represents the name, the fact that it has a mute and a solo, and a volume control, whether it starts or stops, or where it starts and stops. These are more of the parameters surrounding that music or that audio file. So what we can do here is each one of these music segments contains only one music file currently. So they are separate from each other and basically can have different control or different playback from each other. But what we want to do is we want to have these music files stack vertically on top of each other so they can play together at the same time. We hit play once and it will play multiple files together. In order to do this, I have my 3 action segments here: buzzer action, mech action, and spider action. I can hit the plus next to each one of those and reveal the actual WAV file below. And now I'm going to drag my 3 action cues into the music ambient segment and just kind of rearrange this so that they are in the same segment, which will allow them to play together. If I click back on this music ambient segment, I will now see that all 4 of these are together in the same segment, giving them the ability to play at the same time. They are vertically stacked on top of each other. They are effectively using the same timeline and the same transport. So when this is played, all 4 of these will play together. I have independent control of volume, mutes, and solos, but their timelines and their transports are effectively grouped together, allowing them to play at the same time. So now these other segments, my buzzer action, my mech action, my spider action, are not being used anymore. So I'm just going to right click and choose delete, or hit the delete key. And actually music_ambient doesn't describe it very well anymore. So I'm just going to call it music_angrybots, because it really represents all 4 of them playing together. Now we have our 3 stingers here. Just for organization's sake, I'm going to click on my default work unit and go up here to this folder and create a new virtual folder, call it Stingers, and add my 3 stingers to it, just to organize them, get them out of the way, put it in a folder. So that makes it a little bit more neat and organized. All right, so I have my music segment. My music segment plays all 4 of these music tracks together. And just to see that that is true, if I hit play here, yep, plays all of them, plays them all together. And we could certainly wait for it, but you can also trust me that if this plays all the way through, it will get to the end and it will stop. It will not loop. So we need to set up a loop. We need to have the ability for these music files to loop and loop infinitely and just keep looping for as long as we need them to. Now, last round, on Tuesday, when we were discussing 2D platformer, we also needed the music files to loop. We needed to be able to continue to play the files over and over again for as long as we needed. And we did this through the use of a playlist. In order to sequence files to play in a certain order or to have certain elements repeat and loop and play again, we need to use a playlist. So I'm going to click back on this default work unit here, and that will give me access to this button. Kind of over on the right hand side, you got 3 buttons. The middle one here says create a new music playlist container. I relate this to the idea of playlists in iTunes or your favorite music player, where if you wanted to sequence them or have songs repeat, you can do that through the use of a playlist. And I'm just going to call this Angry Bots underscore playlist. All right. Now I'm going to add my music segment to my music playlist. And once I click on that, my music segment editor turns over to my music playlist editor. And I can then add my music segment to that playlist. Dragging it over here just kind of organizes it in the directory structure. But dragging it actually into the editor allows you to change parameters and control everything. So this is really simple. All we want to do is change the loop count. When this starts playing, how many times do we want it to loop? Well, if I press down one time, the down arrow, it'll set to infinite. So every time it comes in here, it'll start playing. Once it reaches the end, it'll just loop back around and play all of these together. And the only reason this works is for the fact that when you composed the music, you made sure everything started at the same time, that it all ends at the same time, so that it makes sense musically as it loops around. The game really has no understanding of your music other than when the last file is over. So it's assuming that you made all of the 4 files the same length, they will never fall out of sync. They will always play together and make musical sense. Okay, so I have my playlist here, and I can play that. Again, it plays all of them together, which isn't actually what we want. We don't necessarily want, when the game starts, to have all 4 of them play. We have to make sure that we only are hearing the files that are appropriate for any part of the game. So that playlist will loop. What else do we need to set up? The next thing we're going to do is set up our music events. So I'm going to go into probably something I should have done a while ago, hit project and choose save to make sure that I'm saving this. Do not rely on Command S. It's a different key command. It's Control S in this software, but I always just choose project save and make sure I'm doing that as frequently as possible. All right, now that we have set up our music and our playlists, I'm going to switch over to my events and open up this music folder. And you will see that there are a number of different events for our music system. It's going to just control how those 4 files play back. So we have something that says play music system buzzer in, play music system buzzer out, one that says end of level, one that says mech in, mech out, player death, spider in, spider out, play music system start, and stop music system. All right, so let's talk about how our music files are going to play back in the game. Kind of what is our intention for this music. When the game starts, it will start all 4 music files playing, but the 3 action cues are immediately going to be muted or going to be silent, so we only hear the ambient cue. When the game starts, we only want to hear the ambient cue. The other files will be playing continually in the background, and all we will do is just raise the volume of that particular piece of music whenever we need to hear that. And when we're done, it will fade out. So we have play music system start and stop music system. These are going to start the entire loop playing. So we have 4 files. Those files are vertically stacked on top of each other to play simultaneously, and they are all the same length, so then when they end, they can return back to the top, and they make sense as they play. So play music system start will start everything playing. Stop music system will stop everything playing. The stop is not really even used until the game is turned off. The music is constantly running in the background and constantly shifting and changing. Then we have buzzer in, buzzer out, mech in, mech out, and spider in and spider out. These are the 3 different robots. These are the 3 different action cues. So we only hear the ambient cue, but the other action cues are still playing in the background. When the fight starts with any one of the robots, it calls the corresponding in event. And then when the battle is over, it calls the corresponding out event. So when the battle starts, when the buzzer shows up, causes a little bit of damage, and the battle starts, it's going to call this buzzer in. We then get to determine what exactly happens with the music. Well, we're going to fade in the music quite quickly. Then when the battle is over, somebody's been defeated, their health points return to 0 or go to 0, then the music will start fading out. We found that a nice slow fade out works quite well to musically remove the music over time. So that is what will happen with buzzer in, buzzer out, mech in, mech out, spider in, spider out. That leaves end of level and player death. With these, we have to determine exactly what is going to happen with the music. End of level, you can have a number of files playing, and we'll say whatever file is playing, we are going to musically fade it out to silence. So we want all music to fade out at the end of the game, or at the end of the level. Player death, if the player dies in the game, they respawn in like this kind of respawn tube somewhere else in the map, and then they kind of go back at it and start back in. You know that when the player dies, they were in battle. The only way to lose health in this game is to fight one of the robots. So that means they were fighting one of the robots, which also means that one of the action cues were playing. 1 or 2, if not all 3 of them were playing. So we're going to fade out all of the action cues and just go back to ambient for the player death. So that's our intention with the music. Let's go back to the start. The first thing we want to do when the game starts, it's going to trigger this play event, play music system start. So we are going to choose an action. All we're going to do is play a file. So we hit play. We can browse to find the music that we want. And even if this is all grayed out, make sure you go into the interactive music hierarchy and you'll be able to find your Angry Bots playlist. You want to make sure to start the entire playlist. That's what will continue to loop. You don't want to make you want to make sure you're not using the music segment or anything below that. You want to use the playlist to make sure that the music continues. So all we're going to do is select that. We're going to play the playlist, and that will start everything up. The other thing we need to do, now when we do this, if I hit play here, it will still play all 4 of them. So we need to very quickly fade out the other 3 action cues. So we're going to use an action that we haven't before, which is called voice volume. We're going to set voice volume. And it gives you some parameters to work with. Let me just move this down here. If I select set voice volume, now what do we want to adjust the volume of? Well, we want to go all the way down here to the action cues. We only want to make sure we affect the action cues. So I'm going to choose buzzer action. And down here we have set voice volume. What are the actual parameters we want to go to? So we want the volume to go down to negative 96. This will effectively mute the file, brings it down so we can't hear it anymore. And how quickly do we want to get there? Assuming that we're somewhere else other than negative 96, how quickly will it take us to get there? Well, we want it to happen immediately, so we'll just set that to 0. And we'll do this for each one of these files. I will choose set voice volume. This time I will adjust the volume of the mech action, and I want the volume to be negative 96. Do it one more time. Set the voice volume. We are going to set it for the spider action. Oops. Make sure you select the action that you want. And we're going to choose it for spider action. And we're going to set the volume to negative 96. All right. Now, one other thing I want to point out is this column that says scope. Sometimes we have a choice of whether it says game object or global. For any of these events pertaining to the music, we want to make sure it's set to global. We don't accidentally want it to trigger more than one piece of music at a time. And there's a possibility of doing this unless it's set to global. Global will basically say any changes that happen to the music happens to all the music. So even if one character triggers one piece of music and another character triggers something else, or an action triggers a piece of music, it will only ever affect the one music system. Now, it can play multiple pieces of music at the same time if we set it up to be that way. But what this will do is not make sure that there's only one global music system controlling everything. All right, so now if I play this event, it's going to play the entire music playlist that has the 4 pieces of music looping around, and it will immediately set the volume of these 3 action cues to negative 96. So now when I hit play, I should only hear the ambient cue. Exactly. All right. So next, let's do stop, because stop is real easy. If we just started everything, well, then we can come in here and just choose stop. And we're just going to stop the music. We don't want to stop everything. We just want to stop that playlist that we started. We'll make sure that's changed to global. And yeah, there's not much beyond that. I'm just going to go up to Project Save. Now I'm going to do all of the buzzer in, buzzer out, mech in, mech out, spider in, spider out. So all 4 music files are playing. The 3 action cues are muted to 0 or negative 96 or silence. So when the buzzer attacks, we want the buzzer music to the volume to come up on the music so that it's introduced and we can start hearing it. So we'll do another set voice volume. And I'm going to choose the buzzer action music. And I want that buzzer action music to go to unity, which is 0. And I want to do it, well, I want to do it not immediately, but very quickly. I'm just going to choose a half second. I typed in 0.5. This will bring the music in very quickly, but it's not going to pop or click because you don't really know where you're at in the music. So it'll very nicely fade it up in a very short period of time. All right, so that will bring the buzzer music in. Now we want the buzzer music to go away. So we're going to do the same thing. We're going to set the voice volume. I want to make sure that this goes back to -96. But I want to do this gradually. I want to do this over time. The instructions mention somewhere between 20 to 25 seconds. We found that a long fade out time works best. Because, well, first off, if you had a really short fade in and fade out time, it would pop in, the battle would happen, and then it would fade out real quickly and feel like the bottom just dropped out of the music. Feel very what's known as Mickey Mousing, where it reacts directly to the action on screen. It works very well coming in quickly because the battle has started, but once the battle is over, you have to kind of cool down and calm down a little bit. It's going to fade out slowly over time. So I want to make sure that this is set to buzzer out, or sorry, buzzer action. I'm going to make sure that it's also set to global. Did I do that for buzzer in? No, I want to make sure the buzzer in is also set to global. I'm just going to do this for the rest of the bots. We got the mech in. Going to set voice volume. I'm going to set it to 0 over 0.5 seconds for the in, and I want to make sure that it's addressing the mech. Go to mech out. I want to do a set voice volume for the mech action, and I want the volume to go back to -96, but do it over 25 seconds. I want to make sure all these are set to global so that it affects only the one global music system. All right. So there's the mech. Let's do one more here. We'll do the spider. Voice volume. Browse. Spider action. I want it to go to 0 after 0.5 seconds. Set that to global. The out. Set voice volume. Make sure it does it for the spider. And set that to global. Make sure that is going to fade out to -96 over 25 seconds. All right, I think that's going to set up most of the action of our music system. There's only 2 left. We have end of level. So for the end of level, we are going to fade out all 4 of these. I'm just going to create 4 set voice volumes. I could probably fade out the music segment or playlist. Those also have volume control, which would fade out all 4 simultaneously. But I like to keep individual track of faders or effective voice volumes. So I'm just going to fade out all 4 of these. I'm going to choose browse, and I'll do the first one to the ambient, do the second one to buzzer action, third one gets mech action, and the fourth one gets spider action. Set all of these to global. All right, now what do I want to do? I want to, this is the end of the game, so let's say over 5 seconds, I want to fade it out to -96. And I'll just do that for every single one of these. -96 over 5 seconds. -96. -96 over 5 seconds. All right, that should fade everything out at the end of the level. And project save. And our last one here is project death. No, project. Player death. So if you die at some point, you were in battle because there's no other way to lose health points. So at least one of the action cues was playing. We're going to fade out all 3 of the action cues. And then we are going to, that'll just keep the ambient cue playing. So again, we become very familiar with these set voice volumes. I'll create 3 of these. I'll make him for each of the action cues. And make sure that each one of these goes to -96 over 3 seconds. So if you want to change the mix, if you want to change the fade times, all of that stuff is done directly in Wise. You are probably best served to bounce your files out of Logic in the most final form that you want, but you still do have ultimate and final control in Wise. Project save. One thing more that I forgot. I'm going to go back to end of level real quick, and once these fade out, I am going to add a stop to stop them playing. And since these fade out over 5 seconds, I'm going to have the stop happen at 6 seconds. There's a delay parameter here, which will delay whatever the action is. So I'm going to choose browse, and I'm just going to stop everything. Now, the main reason for this is when the game restarts, we don't want to have the music playing again. So we make sure that when everything fades out, we just stop the entire system so it can start all over again when the game starts playing. All right, I think that should be everything for our music. We can test this out. I'm going to go back to Project Save. Now, you can click around on these events and play them. However, they will not probably play back as expected. Like if I went and just hit buzzer in, nothing's going to play because the whole system hasn't started. So the best way I find to demo all of this is through something called Soundcaster. If I go to my Views menu, towards the bottom I'll find Soundcaster, and this allows you to play multiple files at the same time and kind of trigger them like they are in the game. So you hit the double arrows in the top left-hand corner of the Soundcaster window and create a new Soundcaster session, which just allows you to set this up. The sessions can be saved and brought back. And I'm just going to highlight all of my music events and drag them into the Soundcaster session, which will allow me to, maybe, not working. It's going to allow me to play these back and control them. There it goes. So it lays them all out. It gives you transports for each one of them. I always figure or think that this sounds or looks like, my bad, looks like an NPC or maybe like Ableton, where you have a whole bunch of buttons to trigger the playback of your sounds. And so I'm just going to go through these and narrate my way through and have them play. So we'll start out with the original the system, music system start. That will start the ambient playing, or actually starts all 4 of them playing, and will mute out the 3 action cues. Now, I did buzzer in. The buzzer comes to attack. So I hit that, and you'll hear the buzzer, the strings from the buzzer come in. Then we have buzzer out. If I hit this, it will start fading out the buzzer cue, but it does it very slowly, like over 20 seconds. And so we'll start hearing over time those low strings kind of fade out. So they'll go away. And then the next one here, let's say the spider attacks. So I hit that play, and it plays the correct file. Keeps everything in sync. So we battle the spider, and that eventually goes away. So we'll hear that kind of arpeggiated bass fade out over time. And then let's see, wait a few more. There it goes. Cool. It fades out. Now let's say the mech attacks. And then we defeat the mech, so we'll have that fade out over time. There it goes. Then let's say all 3 attacks. So buzzer in, spider in, mech in, and then we'll do player death, which should fade out all of the actions very quickly. And then I'll bring them all back in again, and we'll do end of level. Buzzer in. Let's see. Did they stop? Let's stop this. Let's play this again. Let's do buzzer in. Oh. The volumes went away. All right. So the... let's see if we can reset this here. Back in. Let's do end of level here. We'll have everything fade out. And then hit play here. See if these come back. Oh, well, anyway. Now, what I'm going to do is I'm going to switch over and do what I call the baking show or a cooking show, where I'm going to switch over to a final version of this session, so I can also talk about the sound effects. Let me just double check here that I have everything set to global to make sure. I bet this is why nothing was playing back correctly. I think I might have missed those globals. Just make sure all of these are set to global where they can. And just to make sure, I'm going to bring back that Soundcaster session. Let's see if that starts everything back up. Stop. Start over again. Let me just check something out here. So, let me see here. Come on. All right. One element, so let me switch this close. All right. Let me bring out the completed session here so I can talk about sound effects. Come on, computer. Let's close. All right, move this out of the way. This out of here, go in here. I'm going to delete this session. And go get my other one here. Angry Bots. There we go. There it is. All right, I'm going to load this one up. This has everything completed, and it will allow me to talk about sound effects. All right, let me switch over. And I'm going to load up the asset list here and talk about that for a moment. Maybe. Computer's churning real hard through this. All right, so here is the asset list. These are all of the sound effects that you created, that you were working on. And this first column says file name. Those correspond to the sound effects file names, the WAV files that you created. And they are all here. Then we also have a column that says event, and that corresponds to these events here in your session. Sound effects, we have all the events listed out here. So most of this is just connecting the correct WAV file to the correct event. So most of these are just kind of a one-to-one. The naming is very similar. You have a category. These are organization of all the files. That is what these folders are. That's the category organization. There is a column called attenuation, which we haven't discussed what attenuation is thoroughly yet. This is a new aspect to our Angry Bots project, so we'll get into that. And then we have looping. Obviously, you've created some of your files to loop, and we will set up the files to properly loop in the game. All of the ambiences loop. Those are most of the files that loop, and then there is one other file in here, the gunshot, player shooting. That is also a looping file. So let me explain how this will work. In the audio tab, I have imported all of the sound effects files. So I go over here. I would just take all of my sound effects files and I dragged them into the default work unit. Right. I dragged them right here in the actor mixer hierarchy. And then I organize them in different folders, or different categories, the ambience, enemy, objects, and player. That way it kind of mimics what's going on here in the category on the asset list. Then once you have everything imported, you are going to start connecting them to the corresponding events. So you'll see here, again, most of these are just one-to-one, just finding the corresponding event in the WAV file. Every once in a while, you will see multiple WAV files attached to different events. These are 3 different rain files that are going to 3 different rain events over here. They all have different attenuation on them. So let me explain what all of that means. So you imported your ambience file, and it looks like this. Hold on just one sec. So when you imported your exterior rain sound, there we go. Looks like this. You only have this one rain file. That rain file needs to be connected to 3 different events. They say exterior rain 10, 25, and 30. Those numbers effectively relate to the distance away from the sound that you can hear it. 10 is closer than 30. You can think about this as 10 feet. You can think about it as 10 meters. The actual unit of measurement doesn't really matter because we're not exactly sure how things are measured in the game. Some games are very particular about that, but it does change. Consider if your game is on the scale of galactic universes versus a game about ants and everything is in millimeters. So let's just assume that 10 is smaller than 30. So what we need to do here is we're going to take our rain sample, and I'm just going to copy it a couple of times. I'm going to hit copy, come up here to the folder that it's in, and choose paste. Paste it a few times, make a couple of copies of it, or 2 copies of it to be exact, and then I will rename it to reflect the distance away. Oops, or the attenuation, not plus, underscore. There we go, 10. 20. And 30. All right, now we said that all of the ambience is loop. So we can look at the asset list. We know about the file names. Those are the ones you created. We know the events that they need to be connected to. We talked about the categories. Real quick, let's do looping. We haven't seen how to loop a file in Wise yet. So select your file that you want to loop. And over here, there's a checkbox that says loop. And you want to make sure that it's set to infinite, so that it will go around forever. You don't want your ambiences to stop at some point, so we've set that to infinitely loop. Then the other aspect is this attenuation column, and attenuation is volume over distance. So the farther away the sound is, the lower the volume will be. The closer the sound is, the louder it will be. The positioning tab is where we set all of this. You want to make sure to select override parent, if that's a choice. That will override anything that's above it, anything that has been set before. And we want to make sure that this is set to 3D. All of the sounds that have attenuation set need to be set to 3D so that they will pan and position accordingly. And here is the attenuation value. If you hit these double arrows, you'll see 4, 8, 10, 25, 30. These are different distances away from these sounds. Now, we don't want the ambient sounds to play across the entire map. If we didn't use these attenuation settings, your rain sound would happen everywhere throughout the map. These attenuation values put a little bubble around it that says, okay, this can only play 10 feet away or 30 feet away or whatever the value is. So this one is set to 10. We can go to the next one, and we want to make sure it is set to 25, actually. Make sure this is... And then this one is set to 30. All right. That will be setting up all these columns. The only other things that have attenuation on them are doors. Doors you can hear at a distance because a robot could open and close a door. So we want to avoid that. You don't want to be able to hear it. So you will want to set the attenuation values on those also. Then it's really just lining up the sounds with the proper events. Once you have everything connected and ready to go, then you can go to your sound banks tab and you can hit generate, and it will build and put everything into the game. And you can test out the game. You can remotely connect to the game while the game is playing, and be able to tweak and adjust things, adjust volumes, adjust the timing of how things fade in and fade out. Again, you want to absolutely make sure that the game and the Angrybots Wise folder are next to each other. These are just to make things a little bit easier, but these two the Angrybots game application and the Angrybots Wise folder need to be next to each other in order to make this work. So just to show you, if I hit generate here, it'll make sure that everything is, oh, well, I didn't set up everything. Which is at least one missing element. Well, it's because I didn't actually go through and set those up. So if I go to events and choose the correct one here, I'll go back to my designer view. If you get any of the red text, just read it all the way through it, double check, and it'll probably explain to you what is missing. I'll go to my sound effects here, go to my ambiences, set up my 25, set up my 30. Now when I go to sound bank and hit generate, it should not complain. There we go. And again, just to show you, oops, that this worked. Sorry, I went to the wrong place. Just to show you, I can go into right-click on Angrybots, go into Show Package Contents, go to Contents, go to Resources, go to Data, go down here to Streaming Assets, Audio, Generated Sound Banks, Mac, and here today at 4:30, 4:38, it has created that file. So I know it's there, I know it's working, and I should be able to hear everything once the game is running. So there is a series of screenshots required for this assignment. Here in the PDF, down way here towards the bottom, it says, somewhere in here, screenshots. Take a screenshot. Make sure the screenshots are set up exactly like is pictured there. Name it according to the naming format there, and you should be good. All right, so just wanted to do a quick overview of the, well, I guess it wasn't too quick, it was quite involved, but wanted to discuss the overall approach to this Angrybots project using Wise to get the music into the game. Next week, we are going to be using QuickTime to capture a video version of your music and sound effects working in the game. So right now I want to turn it over to the archive, which will discuss some more topics about game music technology, like the use of audio middleware tools like Fmod and Wise, and also game engines like the Unity engine and the Unreal engine. Please contact me if you have any issues with the Wise setup. And other than that, we'll see you again next week. Thank you very much. All right, hello and welcome. It is the second class of week 3, and we are going to turn our attention to the process of how your music actually makes its way into the game. We're going to talk about the technical tools and workflow that is involved in getting your already pre-composed music functioning and interacting with the action and the gameplay happening in the game. So, over the course of the month, we've discussed the basic components of an interactive game soundtrack. We talked about more of the creative aspects of how of different game genres and the history of the different audio consoles and what is possible with them. We talked about how you kind of dissect a game project and figure out what music you might need and how much music you might need, some of the tools that are available that you might interact with the game team and some of the materials that they may provide. How we talked about how do you start a composition from nothing and how do you format your tracks in a way that it actually works and makes sense in the game. So that by the time you reach the end of the composition, you have usable WAV files that can actually be plugged in and work with the game project. We talked about vertical and horizontal orchestration and arrangement of your tracks so that different types of games can use a different musical approach to complete the music soundtrack in the background behind the game action. We talked about the use of looping music, about stingers and one-shots, and we also were kind of discussing the overall process of how you go from the initial idea and start building your music. We've already worked with our 2D platformer game to see a bit of this process and actually getting your music into the game and testing it. So at some point in the project, your folder filled with completed accepted assets that were verified and signed off by the team. You have a folder filled with WAV files that gets bigger and bigger and bigger over time. That your list of to do to fill out the different musical characteristics of this game gets smaller and smaller and smaller. And so initially you start off with this big list of ideas and directions that you're going to head, and you work your way through and narrow those ideas down into what is actually going to be worked and workable and usable in the game. Then you start chipping away at all of those parts and start gathering the different components for your interactive music soundtrack. And you are working directly with the game team, or you're working remotely and sending off assets, and they're approved and verified, and well, they more than likely you don't hit it out of the park the first time every single time, and there's a process of revision, but eventually you land on the approved assets that need to actually find their way into the game. And so now here, more in the second half of the month, we'll talk about the technical process of how your music actually makes its way into the game, so that when a player has a controller in their hand, they hit a button or perform a certain action, they hear the correct piece of music playback, or they hear the correct sound effect playback. And we'll talk about some of the tools and the steps and the process that your WAV files and ultimately your music goes through to create the final interactive soundtrack and game that everybody ends up playing. So one of the best parts to start off with is that all the software that we are talking about today, all of the tools are free, available for you to download and test out. I highly encourage you to test out. We're going to talk about game engines and audio middleware. Game engines like the Unity game engine, which all of your games this month are built in. Also the Unreal game engine, which is another very, very popular piece of software to create games. We'll also talk about audio middleware tools like Fmod and Wise, which are some industry standard software to get music and sound effects playing back with all of the actions and interactivity in the game. So overall, the process that we are discussing is called implementation. Your music is implemented into the game. There is often a job or somebody's role in game development where they implement music and sound effects into the game. They are an implementer. When I talk about this process of how your music makes its way into the game, I like to relate it back to ideas and concepts that you're already familiar with in music production. And I like to relate the idea of implementation to the concept of mixing music for either a song or an album. The mixing is the process after the recording session. Well, maybe they might kind of mix a little bit, but there's typically steps of composition, recording, mixing, maybe mastering. And in the mixing process, let's talk about on the big, large-scale professional side of things with recording studios and budgets and all that sort of stuff. There is a mixing process where you've taken tracks and music that has already been composed and recorded, and the entire job of the recording process is to capture the best performance. And you end up with a recording session that has multiple different tracks for drums, bass, guitar, brass, strings, vocals, whatever the combination is. So the mixing session takes over where you have, 10 or 20 or 100 tracks to mix down to typically a final 2-track stereo master that's then streamed off the internet or put on iTunes or put on a disc and sold around the world. So mixing is the process of taking already pre-composed elements, pre-recorded, and doing something to them, typically on a mixing board or DAW software, using volume and pan and EQs and filters and processors, reverbs and delays and distortions, and there's all sorts of using automation and all sorts of tricks and steps in the process of mixing. And mixing is not just one thing. It's not just one piece of software. It's not just one step or series of steps. If we all went into the same recording studio with the same piece of music, we would all come out with different mixes, slightly different mixes or very different mixes. Even given the same set of tools, we would turn the knobs differently, hit the buttons differently, do things in different orders, and come out with a different result. None of them necessarily being right or wrong in any sort of way. So, and certainly that should be a concept that you have some familiarity with and understanding of. And so then we're going to relate that idea of mixing over to implementation. So implementation is the process of getting your music and sound effects into the game. In some of the same similar concepts of mixing, it is not the creation, it's not the composition of the music, it's not the sound design. All of that stuff is done ahead of time. And you take hundreds, if not thousands of files, typically over time, and crafting them into a final stereo mix or surround mix that anyone who plays the game ultimately hears. And so it's taking a lot of raw elements, or in some stage of completed audio files, and doing something to them in the game with pieces of software to connect them to the game. And again, implementation is not just one piece of software. It's not just one series of steps or workflow that everybody follows. It's a process. It's an art. It's often thought of as half of the process of actually making music work in the game, meaning that, or the responsibility of making it sound beautiful and amazing in a game. Half of that is the actual composition itself, but wonderfully composed music, poorly implemented into a game, is going to result in a bad soundtrack for your game. Same way that a beautiful recording that is mixed poorly is going to ultimately end up with a bad sounding piece of music. So, in this process of getting your music in the game, there are steps in software that we will discuss in getting all of this to work together. So, as a music composer, you know this world over here. This is the world of the DAW. This is the world of music theory and composition. This is the creation and production of the music soundtrack for the game. And this is our domain. This is where we are most familiar and most comfortable, and the main reason that the game team hires us, because they have no clue how to write a note of music or create an amazing soundtrack. So we're certainly familiar with this side of the equation. And over here on the right side, this is the game itself. And honestly, we're familiar with this part too, because at least conceptually, we have to understand what's going to happen in the game to be able to write music for it. So 2D platformer, you certainly understood the idea of their music is going to be divided up into intros, main loops, and endings. That there were going to be 3 variations of each one of those. That totals out to 9 files. And those files are going to be shuffled around in any different order so that they can make a continuous but still varying and random soundtrack. And there needed to be consistency in that composition with tempo and key and progression and style and instrumentation, so that it felt like a linear composition even though it was made up from little pieces and parts. So again, conceptually, we understand what's supposed to happen in the game. We can play the game, we can creatively make decisions about the game, which influences our composition over here. But really, it's these arrows in between of how do we actually get our WAV files over to the game. I can constantly throw my WAV files at the game, but nothing happens. It's not until we understand the process of implementation to understand kind of the workflow behind all of it. So what we're doing here is setting up the interactive behavior assigned to the music mix. So the composition is done, the music is done, but how does the music interact to the actions going on screen? How does it loop and randomize? How does it transition? Is everything going to hard cut from one thing to the next, or is it going to crossfade, or is it going to be in sync and in time with anything? Does that even matter for our particular game? These are the ideas and questions and creativity that's involved in making a strong interactive music mix. And again, we use different software tools to make all of this happen. And so we're going to start talking about some of the tools that take your music from a folder filled with WAV files, because ultimately that's often what you end up with, right? You work all through your amazing production session. You make amazing music in your DAW, and you bounce it out, and you end up with a WAV file. And as you've seen over the course of our projects, that a game soundtrack is made up of a whole bunch of individual WAV files that something happens to them to end up creating what seems like a linear soundtrack. So one of the first tools that we will discuss here is audio middleware. And so audio middleware is software that is in between you and the code. So we as music composers and sound designers and general audio folks, we don't know code just as much as all of the visual folks don't know code. The graphic artists, 2D art and 3D art and animation and textures and motion capture and all of the amazing graphics that we see in games. They are artists and designers just as much as we are. and they don't know code because they've spent their life or spent their life working on a specific discipline in the arts, visual arts or audio arts or music. So the was very obvious quite early on that your best programmers are not going to be your best musicians or even any of your programmers. Your programmers can't write music just as much as your musicians can't write code. And in the beginning or dawn of games, for quite a while, games and game music was explicitly done through code. I mean, the music was created. It was either, well, if you go all the way back to the original Nintendo, it was synthesized and it was literally code generating the soundtrack or the music to Super Mario Brothers that you hear. Later on, it was pre-recorded WAV files, but it was still started and stopped and triggered by code itself. And it became very obvious that your best musicians were not going to be write your best code or even any code at all. And there needed to be some way of taking these two disciplines and connecting them together to make this process easier for both sides. And so middleware has become a very important tool for all sorts of different disciplines that are creating assets and content for these games. So there is middleware for audio and sound effects and music. There's middleware for graphics, animation, physics, networking, pretty much any aspect of game design has software and tools that are used to make that process a whole lot easier. And when we talk specifically about audio middleware, again, I like to relate it back to concepts and ideas in music production that we're already familiar with. I like to connect the idea in a very, very loose way, the idea that a audio middleware can be thought of in the same way as a plugin for your DAW, meaning that your audio middleware allows you to do and interact with your audio in a way that makes the process either easier or it sounds better or you can do stuff that you wouldn't be able to do otherwise, just like a plugin in your DAW. There's all sorts of reasons that we use plugins, but your DAW by itself, whether it's Logic or Pro Tools or Ableton or Reaper or Cubase or whatever you're using, that tool can probably do to record your next song or to record your next album. It could probably do 80 or 90 or even 100% of everything that you need to accomplish to create your next piece of music. But there are a whole lot of reasons that we use plugins. Plugins extend the functionality of your DAW and it allows you to do stuff better or faster. I mean, it sounds better or it allows you to do things more efficiently, allows you to do stuff your DAW by itself could not do. And so much in the same way, audio middleware extends the audio functionality of your game and allows it to do stuff that it otherwise wouldn't be able to do, or it does it faster or more efficiently overall. So audio middleware, in a, again, very general, loose way, could be thought of similar to a plugin for your DAW. And two of the most popular audio middleware tools out there are Fmod and Wwise. And this is kind of like saying Pro Tools or Logic. Well, I guess no, that's not the right way of saying it because that's DAW itself. This is like saying Waves or Native Instruments or something like that, where they're very, very popular tools that allow you to enhance the functionality of your DAW. And again, all of these tools are available free to download. If you check out a lot of different game audio job opportunities, they often mention tools like Fmod and Wwise. And we'll check out some of their websites here in just a moment, but you'll see that they often advertise the fact that they have been used in lots and lots of different types of games. So, audio middleware, like we said, is software that's in between you and the code. We know music, we know sound, we don't know code, but we need to be able to do something with it in order to make it work for our specific uses. In a kind of a very loose way, we don't need to think about using logic this way, but ultimately it is really just code in the background. The software that you are using, when you place audio on a track and you mute a track, or you use a fader, or you add a plugin, really all you're doing is manipulating code in the background. If you thought about it, if you think about it too hard, it doesn't. It's not necessary, because we don't actually interact with the computer that way. We actually use a graphic piece of software to interact with it. But if you peel away the layers of it, ultimately, when you're moving a fader around, it's just changing code in the background. It's just an interface that allows you to tell the computer exactly what you want it to do. And Fmod and Wise can be thought of much in the same way. It comes in two flavors. It comes in two parts to the same package. One side is all of the code, and it is what the programmers use to plug it into the game and allow you to have extra functionality overall. And then there is a graphic, what's often known as an authoring tool, that kind of sort of feels like a DAW, that allows you to that allows you to control and manipulate how this music is playing in the background. And I say not record because all of the content has been recorded and composed and created ahead of time. So ultimately, it takes your audio and puts it in a format that the different computers can read. So a PlayStation speaks a completely different audio language than an Xbox versus a Nintendo versus a PC versus a Mac. They're all proprietary technology. I mean, it's all based off of similar stuff, but they can use different file formats. They can certainly use different code languages, and they are ultimately intentionally set up so they don't really communicate. They don't talk to each other too much. Or it's not the same technology running on both sides. It's probably a better way of saying it. So these tools are almost like a translator that allows you to set up your audio once and make it work on lots of different systems, on all the different gaming platforms out there. Before these sorts of tools existed, if you wanted to move a game from Mac to PC, or from PC to PlayStation or an Xbox, well, Xbox was a little bit easier because it was all Microsoft, but to a Nintendo or something like that, then it had to be completely reprogrammed. All of the audio had to be converted, and it was much more of a process to make it work on multiple systems. And so, at least from the audio standpoint, tools like audio middleware here allows us to set up our audio once and have it work on multiple different places. So here are a couple of ideas about what middleware actually does for us. Some of the techniques that are useful in you designing your music and sound for the game. And you should probably recognize a lot of this stuff because we have been using it to some extent in our game projects. So how do you tell the computer how to transition between different musical themes and loops? Ultimately, you are going to give the computer a folder filled with WAV files, which you already know because you have taken your completed audio files and you go to the 2D platformer game application and you right click and you do show package contents and you navigate to a certain folder and you dump your files there. Then next time you run the game, your music magically works. And that is because the game is constantly looking in that folder and you've told it, or when the game was created, it was told what to do with those files. So this way, the game knows that there are supposed to be 3 intro files, 3 main loops, 3 endings. You're going to randomly choose one of the intro files and then go into the main loops. And then constantly switch and rotate around, shuffle around those main loops until you lose all of your health points. Once that happens, then you're going to transition into the ending. So those ideas of where do I start? How long do I play? How do I play the next file? Going from one piece of music to the next. Do I just hard cut from one to the next? Do I crossfade? Do I wait for some bar or beat where it musically makes sense to transfer? Then you kind of add that up over a game experience that happens over 10 or 20 hours, and there is a lot of control and decisions that have to be made about how the music is going to actually play back. Yes, we've composed it, but it's not just playing from beginning to end. So what are we doing with it? Organizing the assets. By the end of a reasonably sized game, you will end up with thousands, tens of thousands. Bigger games get, well, I would say hundreds of thousands. It's a little much, but many tens of thousands of audio files and minutes, if not hours, worth of game music. You need to, and they're especially the sound effects, are a whole bunch of little tiny files. So you can organize this in some sort of way. You need to have some sort of folder structure. You need to have some sort of approach to organizing everything so it's more easily manageable. And middleware gives you the tools to kind of organize it so that you can say things like, these are all the sounds for this character, and these are all the sounds for this weapon, and this is all the sounds for this level 1, level 2, level 3. And then they can load up and are available as necessary. So it's like loading up a new session. You don't need to have everything loaded up on your computer all the time. You load up a session, it tells you what files you need, and there you go. Game loads up, says load level 1, and the computer hands it all of the level 1 audio files. You can develop a simple looping ambience. We have already found that looping files are very important in our game music. It allows us to musically sit in one place before we transition on to somewhere else. So we can determine, does a file loop? Does it play one time? If it loops, how many times does it loop? So randomized stingers. Well, so we have looping music. We also have random music, or the randomization to provide a little bit of variation to our music. And we can say, how are things random? Do they play in sequence? Do they play in random order? Are they shuffled? Can I play the same sound over again? How long do I have to wait until I can play that sound again? These are all sorts of considerations in how the music is going to play. Real-time audio effects and processing. During gameplay, while the game is actually running, this is probably most of what your game is doing with your audio, is mixing it in real time, mostly changing the volume and pan to determine how loud something is and where it's located around you. Effectively, lots of games use it or handle it differently, but let's just say very simply it would take the top 100 sounds around you and determine how close or far they are away from you, and where in 360 degrees around you that sound exists. And then appropriately mix it and pan it for all the sounds that are heard in the game at any one moment. Gives you the opportunity to test your events in a prototyping environment. You can test how things are supposed to work before they're actually put into the game. Very commonly, it's going to be a day or a week or a month or who knows how long it will take before, from the point when you deliver the audio file to it actually makes its way into the game. Ultimately, you are probably not the person who's actually putting that file into the game. It's left up to somebody else. And so they have to receive your submission, they have to put it into the game, and then send it back to you somehow. And often game teams are, this is necessary for everybody, so they're very, very good about this. Either give you the means to test it out locally on your computer, or every couple of days they'll release a version of the game that everybody can test out. And then ultimately allows implementation of your audio into the game. That's really what it's there for. It allows you to set up the interactive behaviors. How is music going to play? How is it going to loop and transition and mix when ultimately it's the computer controlling everything. It's not we don't have direct control over everybody playing that game. So we have to create a interactive mix that allows for those changes to happen. So I'm going to take a quick pause here before we get into our next topic and kind of identify more details about how elements of audio middleware works. Hold on just a sec. I'll come back in just a few. All right. So, as I mentioned, one of the main things that your game is doing in real time is mixing the volume and pan. One of the most basic components of an audio mix is volume and pan, right? Whenever you're working on music, everything that you add and subtract and EQ and add an effect to, you're constantly going back to your volume and pan to adjust everything. And one of the big challenges in game audio is that you don't know what's going to happen at any one time, and so you cannot necessarily prepare the mix for it. So often what you do is create boundaries of your mix, create minimum and maximum values where no sound is ever going to get any louder than this value, and it's never going to get any lower than this, which is typically silence. So it'll either go from complete silence up to ever being this loud, whatever that value is. And then the game can control the volume by different parameters that are happening in the game at that time. And one of the most common ways that volume is perceived in the game is over distance. If you need to create the sense that a sound is getting closer or farther away from you, volume is the main way to go. It's typically a combination of volume and low pass filter, so it rolls off the highs. It seems a little bit more muffled, but it seems like it more from a distance. So volume is often attached to distance, or that's how you create the sense of scale and size and distance in the game. And then the other aspect is panning. How does it know where anything is positioned in the real world, or not in the real world, in the game world? And the answer is it's the computer, and it is constantly in control of the game world. And so it constantly knows where you are and where all of the sounds are in respect to your position. So it always knows in which direction you're looking, even if you're turning around, and it knows where those other sounds exist in the game world. So a mile off, an explosion happened in our game, and so we hear it from the right, and the volume is reduced and a little bit muffled to create the sense of distance, and you can kind of pinpoint it or spatialize it to a location and head off in that direction. So, as I said, the game pulls the closest however many sounds around you, figures out their importance of how necessary is it to be as a component of a mix, right? If you have a firefight going on and you have 10 players all in an area launching off the loud rockets and explosions and weapons, you don't necessarily need to hear every single one of their footsteps. And so it makes decisions on importance of sounds and proximity of sounds and what is the most important sounds that you hear in any one time. And then it adjusts their volume and panning accordingly. And it does this at 30 or 60 times per second. However fast the game is updating. I mentioned previously that games work off of frame rates, and the faster the frame rate of the game, the smoother the action, smoother the overall mix can be. And so at this quick pace, it is determining every sound that needs to be changed and adjusting the mix accordingly. So we have variable volume, we have variable pan, but as I mentioned, you might have large periods of time where there's lots of sounds going off at the same time. So, and then you also have periods of time where there's very little sound. And how are you going to create a mix when you don't know what's going to happen and it's going to go back and forth between the loudest grouping of sounds that you've ever heard in the game and a relatively quiet, less action-based part of the game. And ultimately, to control your overall dynamic range and the overall be able to control the volume mix, dynamics processors are put into effect during gameplay, where you have compressors and limiters that can control groups of audio signals and adjust the mix accordingly. So here we have what looks like a bit of a signal flow, or it's mostly like how stems and groups of sounds are kind of routed together ultimately to go out the main output. So up here, the main output would be the output of your PlayStation, your Xbox, or your computer. Right before that, there's often a limiter. And this is to prevent some random game blowing up a consumer speaker system, like the general public's speakers, right? Whenever Sony or Microsoft releases a game for their game console, they check that game because it's made by other developers, and they want to make sure that that game is going to operate as promised on their gaming hardware. And so one of their certifications that they do for their games is to make sure that it doesn't overload and produce too much signal to create issues with somebody's audio system. So there's a limiter that's often a kind of a brick wall limiter that says, okay, you can't go past 0 here. This is the final stop. And this limiter you never really want to touch either. You are going to make sure that all of the audio as it's mixed before that levels properly so that it doesn't overload the master. So we got a master bus that's fed by dialogue, sound effects, and music. Each one of those has a compressor. Notice that there isn't much involved with the music because the music is all kind of taken care of by the composer, and there's like the mix is already done. Most of what the game has to do with the music is just play back the right file at the right time. There is a compressor on the music. It's not really there for the mix. It's there. Notice it has a side chain. So side chain from the dialogue. Critical dialogue, things that are absolutely important. If necessary, conduct down the music to make room for that dialogue. It's a very common approach. Then dialogue might be split out to critical and non-critical dialogue. Sound effects are broken out into lots of different categories: weapons, ambience, vehicles, objects, explosions. Notice explosions has its own limiter so that you don't explode too much and cause issues. Things like vehicles spread out to or split out to engines, vehicle impacts, and skids. Vehicle impacts has its own limiter. So certain things that can cause havoc to the mix have their own control. So you have real-time processors, dynamics processors, limiters. These things allow you to have some semblance of your overall mix and put either brick walls or soft walls that allow you to head up to a level but not go over. If there are real-time dynamics processors, that also means that there are real-time time-based processors. These are relatively newer to the industry, the past 10 years or so, where you have similar types of effects processing that you might get in your DAW. So we have things like reverbs and EQs and distortions and delays that give you a lot of environmental effects. So you could have a reverb that gives you a sense that you're in a big airplane hangar versus a small wood hallway, or now you walk outside and there's little to no reverb. Different approaches, and third-party plugin developers are starting to create plugins for these tools. Isotope, Waves, let's see, actually right here. These are popular plugin manufacturers that are also finding clients in the games industry. One of the first was the Waves plugins that were built for the Xbox 360. It's the same processor. They built the C4 compressor, the Q10 EQ, the Renaissance Reverb, and they built them as plugins that could run on the processor of the Xbox. And this allowed them to go into the DAW and set up their plugin, save a preset, and then dump it into the Xbox so that the next time they run the game, they can turn it on and off as needed. So WaveArts, McDSP, Isotope, traditionally and still audio, they mostly serve the music industry, but they are also finding clients in the games industry. Hold on real quick. So let's take a moment here to talk specifically about two audio tools, audio middleware tools, Fmod Studio and Wise. And Fmod has been around for quite a while, maybe about 15, 20 years by now, which is an eternity in the game world. But they're developed by Firelight Technologies. They are based out of Sydney, Australia. You'll see this is very common, all the different platforms, Xbox, PlayStation, that's actually updated to the Switch now, Wii U, Mac, PC, iOS, Android, a lot of different platforms. Pretty much, again, wherever you want your game to be released, they have a set of tools that works for that particular system. And it's the same tool. It just, on the front end, it looks like the same graphics tool for everybody. But on the back end, it speaks all the different languages for the different gaming consoles. So let me actually jump to, let's see. Hello, mouse. Let's check this out. This is Fmod, fmod.com. And these are all of the tools that are, or just some insight into some of the tools that are available. Some videos and some games that you can check out. Let's see, if we go to download here. Excuse me. If you go to download, you can download Fmod Studio Tool. Here's the Macintosh version. And you can check it out, and it looks something like this. So let me load up a project here. Did I do that? There it goes. And bring it back. What you might notice here, let's bring something up, is that it doesn't look too different from a DAW. Yes, it certainly looks different, but there are certain characteristics that can feel quite familiar to an audio developer. You have things that look like tracks, you have things that look like regions, you have solos and mutes and knobs and buttons and sliders. You have a surround panner. There's an organizational structure over here. You can zoom in and out of your tracks. You have different timelines. So there are some looks and characteristics to it that would feel familiar to a music composer or an audio developer. And that's the market that they're going after. And so they're trying to create tools that are that somebody can really work with, and that they don't have to take too much of a learning curve to jump into these tools. So you would have to have a discussion with the game developer to get a sense of whether they want to use these tools. They are free for non-commercial and educational purposes, but eventually they can become quite expensive overall for a full development game. But those games are typically running in the millions of dollars of development costs. So let's bring up a music track here. Show you what's happening. All right, so you see things like rest. This says low, medium, high, end. And there's a wave file in here, and there's a whole bunch of yellow lines, and those represent bars or beats of where the music can actually transition. Basically, all of those are different exit ramps for the music so that you can transition from one piece of music to the next. It allows you to determine where you want the transition to start and where you want the transition to end. And the music can switch and change. Zoom in here so you can see a little bit more of the music. You'll see that they are all on beat and downbeats. And there are values up here of an intensity of your music. As the intensity increases, the music also increases. We got low, medium, and high. This is a lower intensity, medium intensity, and high intensity music. And as soon as it goes to medium or high, it'll wait till the next logical point, which is only a few beats away, before it transitions into the next phase of the music. So what you can pick up from here is that it's not that unfamiliar to a music composer. It's not all that outside of the realm of possibility that you might understand and start working with these tools. I definitely encourage because it's very much like handing your music over to somebody else to mix. If you never touch any of these tools and you never get an understanding of what's happening in the background, then what you will be doing is delivering your WAV files. You'll put them on Dropbox and deliver them that way. You'll throw them up on a FTP. However, you would ultimately deliver the files, and then a programmer would take those and, again, do something with them in the code to make them work. And then it's like somebody else mixing your music. They would do stuff. They are not musicians. They don't necessarily know how the music is going to transition. So you want the ability to have tools like this to control exactly how things are going to sound. You end up getting much better results if you give these sorts of tools to the music composers and developers to get an improved end result. So just a couple of screenshots about Fmod and what it can do for you. a tool used for authoring interactive music and events, used by sound designers and composers. Again, tracks, solos, mutes, faders, knobs, very identifiable actions for music. So they have a lot of pretty big name games out there. However, a lot of game developers have been switching to Wise. Blizzard now makes Overwatch, which is switched over to Wise. The Batman series switched over to Wise. BioShock switched to Wise. But a lot of car games end up using Fmod Studio because of its ability to do engines, car engines, motorcycle engines. Is a pretty powerful tool. Let's go back over. Where am I? I need to. Where'd my other tab go? Did I close it? Nope. Find it. Hold on. So, like I said, you can go to download here. You could download Fmod Studio authoring tool. This is all the Fmod Studio Programmers API and low-level programmer API. This is all of the code. You don't need to download that, but you can see all of the different gaming software, gaming hardware that the Fmod works on. Plugins. There's a mastering limiter, audio gaming weather, allows you to synthesize weather effects. Audio gaming motors allows you to synthesize vehicle effects, and actually works and integrates with Fmod Studio, with Unreal and Unity. So there's a lot of games that you can get that actually utilize your, that can actually use, that you can rip out all of the sound effects and music from it and put in your own custom sound effects and music. Simple pricing, free for us, free for free for educational purposes, non-commercial reasons, even up to $500,000 in the budget. It's free for one game per year. But beyond that, then if you get to be a bigger developer and you're making a lot more money off of your games, this is where they actually keep their business going. For anything over $500,000, it's $5,000 for Fmod. Anything over $1.5 million, it's $15,000. So this was the original price, or even a little bit more than that. But $15,000 or more is the full price for this software. But they do have multiple different platforms for different types of games. We saw Fmod Studio API. That gets us into the next one here, Wise. Wise is developed by Audio Kinetic. They're based out of Canada. Again, they're available on all the different platforms, Xbox, PlayStation, PC, Mac, iOS, and Android. Here is their website. And you can go to download Wise, maybe. There it is. And let's see, download Wise. You can download it. You download the Mac version. And let's see. I've always thought that Audio Kinetic is a little bit newer to the game. I mean, it's still been around for a little while, 7-8 years. And I have always thought that they watched what Fmod was doing and then just did it cooler and better. Like, they did everything that Fmod was doing and then added some extra functionality. And a lot of these games, very, very popular games, have been used Wise to create all of their audio. Right, the Assassin's Creed series, the Batman series, the BioShock and Borderlands series of games. Depth, that's the game I'm working on. Destiny. What else is out there? Just lots and lots of games that are extremely popular and use the Wise tool set, which is why you see a lot of these companies asking for skills and requiring skills in understanding some of these tools along with the actual composition. So we got download, we got customers. Let me load up Wise here. And it's, I've always thought it's not as pretty as Fmod. That is one thing that Fmod has going for it, is that it looks a whole lot better. Let's see here. Hold on. It's loading up. There it is. So Wise is a little bit more gray overall, but you have the ability to set up the characteristics of the sound and how they play back, something that looks like all of this over here. You have the ability to build curves like this. Let's do this. Build different curves for the how the audio is playing back, volume, reverbs. You can do. You can connect to the game and watch how the game plays back in real time. There is the mixer where you can take let's see here. Let me get something that'll work. Oh, I guess this. Oh, there we go. There we go. Do stuff like this. There we go. And you can actually have a real-time mixer for sounds in your game. There's a meter over here. There's a surround panner. There's all sorts of different controls that you have to the sounds. So, like a lot of things, it's not very pretty, but it's certainly extremely powerful in its capability. This is mainly the tool that I use for the game projects that I'm working on. It's a very popular tool set out there, and there are a lot of like tutorials and game projects that you can use to create your own kind of demo and showing off your skills in these tools. So they're based out of Canada, Audio Kinetic, based out of Canada. All the different platforms that are available. We saw a lot of different games that are available for and use the Wise system. The Wise Designer, that's the software that I was showing. Again, it has things that look like crossfades. We've got a transport down here. You got faders and menus and inserts and solos and pans and aux sends, and this over here looks like a busing structure. It's kind of like stems and how things are going to mix together. There's your surround panner. There's all sorts of familiar tools for audio developers, but a specific function for it in the game itself. All right, and so our last topic here, we want to discuss the main tool that is used to create games, known as game engines. So previously, when I said that, or compared a previously when I compared the audio middleware to a plugin for your DAW, I said audio middleware extends the functionality of the audio for your game just in the same way that a plugin extends the functionality of audio for your DAW. So if audio middleware is like a plugin, then your game engine is like the actual DAW, meaning it's the main tool that you use to make your game. Just in the same way that your DAW is your main tool that you use to make your music. And game engines come in different flavors. Different companies have their own technology. Some of them are quite popular and well known. Others are very small and independent. It used to be that a new game engine was written for every single game. Maybe only if it was a sequel would they use some of the same stuff, but a lot of times it was written from scratch every single time. But that didn't certainly wasn't the way to go about it, and so different companies started to create tools that were general enough to do all sorts of different types of games. It didn't have to be just a racing game or a cards game or a puzzle game or a first-person shooter game or action or adventure or whatever. They could make tools that were general enough to make all sorts of different types of games. And so a game engine is a tool set. It's like a toolbox of different pieces of software that people use to make games. And there are tools for the graphics, there's tools for the programming, there's tools for the animation and physics and how things actually look and perform in the game. And then there are tools for the audio and sound. And so everybody is using a similar set of tools to accomplish the project. So your choice of game engine is very, very important, just in the same way that when you're recording your music or writing a piece of music or whatever, your choice of DAW is very important. Often it's a personal choice of what tool you feel most comfortable using. But if you're working on a larger professional project, you have to make sure that everybody is comfortable using Pro Tools or Logic or whatever DAW you are using. Same thing goes with a game engine, but you could easily have 10 or 50 or 100 or even 1,000 people or more working on a game project using the same set of tools. So picture if 1,000 people had to get into the same Logic session, how much of a nightmare that could be. So these tools often are set up also so that a lot of different people can get in and work on their little section of the game to create the final result. And so game engines often come in two different parts, just like middleware. There's all of the code that the programmers can use to create the games. And there certainly are programmers out there that can start from a blank text file and start pounding away at the code until they end up with some semblance of a game. And most programmers and most game designers don't want to start at that level. They don't want to have to reinvent the wheel from scratch every single time. When you want to create a game, you don't want to have to reinvent how to draw a pixel on the screen or how to have the mouse and the keyboard and a game controller work, how to connect to the internet and do a multiplayer game. Those are sets of tools that already exist, right? If it's not like whenever I want to go build my house, I don't want to have to reinvent the concept of a hammer and nail every single time. They already exist. I can go to a store and buy hammers and nails and all of the other materials that I need and go build my house. Same thing goes with a game developer. They don't want to have to reinvent the concept of a hammer and nail just to build their game. There are tools out there that other companies have created to allow companies to build the games. Most game designers, all they really want to do is tell a great story, create amazing characters, create great graphics and audio and design, and tie it all together with powerful tools in the background. And so different game companies like the Epic Games. Epic Games makes the Unreal game engine. Unreal games have been around for a very long time. Since the late 90s, the Unreal games have been very popular. Unreal, Unreal 2, Unreal 3, Unreal Tournament, Unreal Tournament 2013 and 27. I don't know. There's all sorts of different ones. And they also made the Gears of War series, a game called Bulletstorm. And if you make a game, you have to spend all of your time and money and efforts in making an awesome game, and then you have to turn around and sell it to everybody. But if you realize, a lot of these companies realized that they had the tools that they could sell to other folks to make amazing games. And then they didn't have the risk of selling that game. They could just sell the tools and make their money that way. And so that's what a lot of game companies have done. Other popular game engines are, well, the Unity game engine, which all of our games are made in, and a lot of mobile games are made in the Unity game engine. The Unreal game engine, which you might already been familiar with. If you play a lot of games, often you see the logo that pops up on screen. What else? The Valve, game company Valve, has the Source engine, which makes a lot of their games. Team Fortress and Left 4 Dead and Half-Life and Portal and some other awesome games. Electronic Arts has the Frostbite engine, which came from Battlefield. Call of Duty and Activision has the Call of Duty engine, which is based off of an older version of Doom and Quake, which is also an extremely popular engine for quite a while. So a lot of these companies have gone on to make their own set of tools. And those tools come with all of the code that the programmers use to make the game, and often something called a world editor or a level editor, some visual graphic interface that all of the graphics folks and all of the audio and sound people can get into and actually see everything. So there's somebody who goes in and paints the sand, and there's somebody who goes in and plants all of the foliage and trees. Somebody animates the water to lap up on the beach and the birds to fly overhead. A lot of these icons represent sounds in the game world, where since sounds aren't physical, and well, they are physical, but they're not visual. You can't see them. They put an icon in the center of that sound and often create a sphere around that to display where the sound emanates. So game engines are not just for audio. They are an entire toolbox for all sorts of different disciplines. Most of what the game is doing in real time is generating the graphics. That's mostly what takes up all of your processing power. When your computer starts sweating playing a game, that's really what it's churning away at, because the graphics don't exist in their final form until somebody actually plays the game. So they are rendered in real time to create the visuals that you see on screen. So a lot of what the game engine is doing for you is creating amazing graphics, because graphics sell the game, and everybody is amazed by games because of how their graphics look. And so a lot of time and effort is put into that side. There's the gameplay. Gameplay is, how does the game actually play? What are you doing? How do you control it? How do you run and punch and jump? And how do you go through the levels? And what are the objectives? And what's the story? And like, what's the actual game? If you turned off the TV and turned off the sound, well, you really couldn't play the game, but what's there? What's actually, what are you doing? Networking. The fact that your computer can talk to many different computers across the world almost in real time to play a video game is an amazing feat in technology. And but that technology already exists. The internet already exists. How one computer talks to another already exists. You don't need to reinvent that. You just take the tools that are available and apply it to your own game. Physics and AI are whole fields of scientific study that game teams cannot, again, reinvent the wheel. They don't employ scientists that study artificial intelligence or study physical nature of our universe to determine how things fall and blow up and run and jump. And so these sorts of things come in the box, are a set of tools that allow you to perform all of these actions. And probably rightfully so, audio gets a pretty small sliver of what the game engine is actually providing for us. And that's really because all of the heavy lifting has been done by the composer and the sound designer ahead of time. The music and dialogue and the sound effects are really the most real components of the game. The music has to be composed and is often recorded, performed by acoustic instruments, performed by live musicians. The sound design is recordings of real cars and real weapons, and the dialogue is from a real human. So the computer doesn't need to generate all that stuff. Audio exists separately from the game and is then implemented into the game versus the graphics. The graphics don't actually exist until the game is played and rendered. And so mostly what the game is doing with your audio is making sure it's playing the right file at the right time. So two of the most popular game engines out there are the Unity game engine and the Unreal game engine. And if you play a lot of mobile games, web-based games, the Unity game engine really became popular in this space. Game technology for a very long time was really quite expensive. We'll see that the Unreal game engine could go upwards of $500,000 or originally even $1 million just for the software to play your game or to create your game. And that meant there was a whole lot of developers that were never getting access to the best technology. And then the internet comes along and mobile gaming and mobile devices come along, and there's all of a sudden this new a new market out there for smaller games to be able to be digitally distributed. So they didn't need publishers. They didn't need a box or a physical media to put on a store shelf. They could make their games in their bedrooms and distribute them and have international distribution through things like iTunes and the iOS App Store and Google Play Store and Steam. These are online game game stores that allow people to purchase their product. And that meant there are games like Angry Birds that came out of nowhere and makes millions upon millions of dollars that the other game companies were not getting involved in, like the game tools. It's like if Avid with Pro Tools never left the high-end recording studio market and never ever tried. This happened in audio too, right? Audio recording was pretty much the world of high-end studios that cost a whole bunch of money. And so tape recorders and hardware effects racks and eventually DAW computer-based recording software cost lots and lots of money. And then computers got faster and cheaper and smaller, and audio production went into people's home studios. And now all the software and hardware that had to be only sold and marketed to the biggest and largest and most expensive studios now had this whole new market that they had to address, and smaller independent producers. Same thing goes with games. It shifted from only the big $1 million games into smaller independent developers, and that's where Unity came in to fill this space. The Unity game software, they're based out of San Francisco, and it costs $1,500 or $75 per month. And let me just, here's their site, and let me just, we might change their pricing here. What do we do? Get Unity now. So you go to unity3d.com. Not where I started? Yeah. Unity3d.com. And you could get the free version of it. Download this. This is what all of our 2D platformer, Angry Bots, everything was made in the free version of Unity. And see, they have different price points for the different services. Like all these Plus, Pro, and Enterprise, you don't need that for audio demo work. Only if you were making a really big professional, probably online multiplayer game, would you need some of that support. So you could download this software and get access to all sorts of games. One very cool thing that they have is the asset store here. And you can download different assets, different projects. They have Unity Essentials down here, and this is where 2D platformer is, but there are all sorts of interesting games. Survival shooter, space shooter, tanks. What else is cool on here? The adventure game. Where's the village? Viking Village. So these are all sorts of different games. We saw this actually on the Fmod website. Because you can use Unity and Fmod together. It talks about how to take this game and work together with it through Fmod. Here's a space shooter type of game that has really kind of cool graphics. It's like a 2D space, like, I don't know, Space Invaders or I want to say Missile Command. What am I? Space Invaders. I guess that's the only one I'm thinking of. Tanks. A small little desert tank shooter. Adventure game. This one looks pretty cool. I was kind of thinking about doing this it's like brand new. It just got released like, I don't know, quite recently. December 21st. So I've thought about bringing this into the class. It's kind of short, but it's definitely a fun little game project. Viking Village. This is another very cool one here. It's like it's a Viking village. It's a gorgeous environment to have and display different elements of music. So, really cool projects that you can check out. The other cool aspect about this is that there's a music and sound. There's an audio section and a music section, and there's all sorts of different people selling packs of music for different prices. So you could see, okay, here's 8-bit action music. What are they selling for 50 tracks for $40 that they can sell? And certainly it is a non-exclusive agreement because you're selling it on an asset store. But it's a great way of passive income where if you have tracks, you're just constantly writing music, and you can create a pack of 20 tracks of music. You can put it up there and typically in a theme or a style, put it up there and sell it and see. I see a lot of these different companies or groups of people selling, like they have 10 of them on here, and they probably making at least something off of it. So definitely check out Unity, unity3d.com. It is available on Xbox, PlayStation, PC, Mac, iOS, Android. It's basically, again, like all the other software, you can use it for any platform that you want. It's set the game up once, and it can work on multiple different platforms. It does use a version of Fmod, but by itself, like default. But it's like behind the software. It's like you don't even see it as Fmod. But it can use Fmod Studio and Wise, the two pieces of software that I showed earlier. Then there is the Unreal Engine. The Unreal Engine has been, like as I mentioned before, very popular for a lot of very high-end games for quite a while. And they made a lot of very popular games over the years, and then realized that they had a set of tools that they could sell to other companies to make their games. And so the Unreal Engine has probably been the most popular third-party game engine out there available. It is freely available for you to download. I've chosen not to use it for our game projects because it's quite heavy. It runs very, very powerful games, so it's very powerful software. It takes a pretty large install, and it can make our laptops sweat pretty hard. It can push the processing power very, very hard. So it's not. Unity is kind of a lighter game engine overall, and it works out because it was initially meant for more mobile games and still has that history to it. So the games run. I can assume that the games are going to run a little bit more smoothly on our laptops through the Unity engine. But you can definitely download and check out the Epic from the Epic website. The Unreal Engine. That looks like, where'd it go? Looks like this. And so These are some of the games and things that it's showing off in the background. The Batman games, the Street Fighter games. I don't even know what that game is. Oh, that looks like Paragon. Works on all these different platforms. They're pushing virtual reality. I mean, they've just got some really, really high-end stuff. Actually, let me see if I can find it. I just found this today. State of the Unreal Engine. Yeah, they just released a really cool video about the Unreal Engine, about what they're doing it in 2016. It was used in Rogue One, Star Wars story. That kind of lends to the idea that it was very, very heavy, very, very powerful processing. They use it to generate like cars in TV commercials. They use it in live broadcasts and stage shows and lots of games, lots and lots of games. So it's pretty widely used software out there. If you get a chance, you can definitely check out some of what it's capable of doing. Marketplace, can you get on there? There's also, yeah, a marketplace here that sells different assets. And there is a sound effects and music section. So people making music and selling them for different prices, which is pretty interesting approach. Just another means to sell your music out there. And you can download games. Let's see, categories or projects. Community samples. Yeah, you can download game projects. This one looks absolutely gorgeous. This is free to download, and it's an environment to you can make music and sound for. You could probably, I'm sure you could navigate that around in 3D. So really, really cool stuff. Available for free. There are tutorials, there are game projects. They all need audio and sound. I often tell people that are interested in checking this stuff out, create a demo project that you can show off to different game companies. Show yourself recording the sound, show yourself in the DAW, creating the music and creating the audio. Show yourself in the game tools like Fmod and Wise, and then the Unreal Engine and the Unity Engine, and you've got an amazing demo to show off what you're capable of doing with all this software. So some very interesting stuff out there. Again, the original license and the full license could be upwards of $500,000. But they have a current pricing scheme. Let's see if it still is the same. Oh, did I close that? Let's go. There it is. Unreal Engine. Let's see. About. Oh, they don't have a price on here. Let's see. Overview. How much? Not cheap. There it is. Use for free. Pay 5% when you ship. So they are going for a straight 5% cut of your profits, which is an interesting way of going about it. But instead of doing that, some companies just take a flat rate, which can be many hundreds of thousands of dollars. So for the free guys, it's just a little cut. For the small games, it can either be free or a really small percentage. Or for the bigger companies, they kind of scale up from there. Free for educational purposes, for our non-commercial reasons, we can completely dive into it and get access to it. So available on all these different platforms, and uses a system called Microsoft X Audio 2. Epic Games and Microsoft have been buddy-buddy for quite a while. Epic Games did Gears of War, which was a Xbox exclusive, and then Microsoft has taken over and done the new Gears of War 4 that's coming out. And so they use a lot of Microsoft tools like Xaudio 2, but you just see it inside the audio software, and integrates with Fmod Studio and Wise also, so you can use some of the third-party tools. So, like I said, your game engine's sort of like your DAW, in that by itself it can do 80 or 90 or even 100% of what you actually need to get done, but with the default audio system. But it can integrate with tools like Fmod and Wise to give you extra functionality, just like a plugin. So that gives you some insight into some of the technology and tools that are used in the process of getting your music working in game. All the software that we talked about is free. I highly encourage you to download and check it out. To check out some of the tutorials, check out some of the demos, and find other games that you can take and put your own audio and music and sound effects into. So if you have any questions about technology, or you want to get started with any of the software, or certainly if you have any questions about the class or the project, please let me know. Otherwise, have a good afternoon, and I will see you again on next Tuesday. Thanks a lot.